Welcome to ePathshala, postgraduate program for Masters in Architecture. Today we will be looking at solar geometry. As previously we have spoken about eco houses in the previous modules, today we will look at solar geometry. This interactive model will show how to use the solar chart, shadow angle protractor, and to find the altitude azimuth of the sun and the vertical and horizontal shadow angles. This is very important for architects to know all this. Reason is, to design any eco house, we need to understand how the sun movement happens within that area. Now, as well as we will also look at the shading mask, how to draw a shading mask, and we will propose of findings of hours and days and months and years that direct solar radiation would be incident on the windows. Similarly, we also will look at an example at calculating the amount of air conditioning load that has an impact on a window, and by using solar chart and shading mask, how can we reduce the air conditioning system loads. Firstly, this is how a solar chart is drawn. This is a different configuration. I would not get into the details of how a stereographic projections solar chart is drawn, because that will require a separate module in itself to understand how to design it. The reason why this chart has been put up is there are two different charts. One is a stereographic chart, the other one is an orthographic projections. So, what happens with stereographic chart is basically is based on the natural movement of the sun, but there is charts which are available online where you have the standard time included in it. Here the standard time is not included. So, similarly, now we will look at what are the different charts. Now, what I have done over here is I have put the charts in a sequence. It starts from 0 degree, that is the equator, and it goes up to 60 degrees on to the north as well as 60 degrees south. Now, how does it work? The reason why this chart has been done, as you can see, in a 0 degree, the top, the northern hemisphere and the southern hemisphere, the northern hemisphere is always on the top and the southern hemisphere is always on the bottom. So, on the near the equator, you can see that the sun travels equidistance, like it travels half the year in the north and half the year in the south. Similarly, when you go down towards the northern side or the northern hemisphere, which is on the left chart, you can start looking at it that the sun starts moving more towards the southern end. For example, 20 degrees in Indian scenario would be somewhere just below Mumbai, would be a ideal place where you can see that predominantly the sun movement happens on the southern side, and only 1 month or 1.5 month or 2 months the sun moves on the northern side. As you go higher in latitude, 40 degree the sun is predominantly on the southern side. As you go to the latitude of 60 degrees, the sun is on the completely on the southern side, but you could see that during the sunrise and sunset, the sun goes almost towards the northern. So, it is almost towards northeast in 60 degrees when the sun rises and sun sets at northwest. So, it shows that the days are longer during summer and days are shorter during winter. Now, to read and understand in more detail as to what these different lines are there, we will go look at the solar chart. Now, I will take few minutes in this to explain this, because I think most of us have seen this in our bachelors as architect students, and maybe few charts may be lying in our offices, but we have never taken into consideration looking at this into detail. Now, when you look at that, the first one is when you look at the central sphere, the circle, and there are certain dimensions which are written on the circles, that is basically your azimuth. Now, what is azimuth? Okay, you can observe me and look at me and see what the way I will explain to you in azimuth is. You are standing in right where you are standing. For example, you are standing on earth, okay, you are facing north. Now, north normally in a solar chart is 0, and imagine the earth surface has been pressed down. So, instead of the earth being spherical, now you are pressing the earth down into a flat surface. When you press the earth into a flat surface, then you are facing the north. Whatever the circumference of the earth is, the entire earth from starting from north, okay, northeast, east, south, west, and coming back north, that would make it 360 degrees. So, that is basically azimuth. So, the location of the earth in respect to it would be the azimuth. So, basically you are making the earth flat and looking at the earth in a two dimensional aspect. Now, what is altitude? Now, where is altitude in the solar chart? If you observe closely to the solar chart what has been provided to you, you can see the altitude has been written on the vertical ones, and congruent circles, concentric circles shows the altitude on it. Now, when you go closer, the altitude starts from the 0 from the outside, the outermost concentric circle, and comes down to 90 in the center. So, what is an altitude? It's basically, in simple terms, is the position of the sun with respect to earth. So, if you look over there at in the east, in the mornings the sun rises from the east. So, the first position of the sun would be, if you look over here, then it will be almost 0. As the sun starts moving, the sun rises and it comes down during the noon. The sun is almost like we presume it will be overhead. So, in this chart the sun could be at around 70 degrees, 77 degrees. Similarly, when it comes back, it comes down back to 0. So, basically the movement of the sun with respect to earth, the angle which it makes is nothing but an altitude angle. Now, these two are clear. These are very important to understand a solar chart. Now, there are certain amount of laterally curved lines which are shown. Now, these two laterally curved lines, one which is cutting the concentric circles horizontally, okay, that is from east to west, that is basically your months. Now, here you have the months starting from Jan till December. Similarly, the months which have been laterally cut, vertically curved lines which are cutting the months, is your time. Now, when you look at a solar chart, there are 4 total aspects that you are looking at. One is the azimuth, that is basically with respect to earth. Second, altitude, the angle the sun makes or travel path of the sun with respect to the earth. Third is basically the months throughout the year, that is 12 months of the year. Fourth is the hours. Now, it is very fascinating to see in the chart that during as we know that we have the longest month, the longest day, the shortest day, and equal days. Now, the longer months are called the summer solstice. Now, in summer solstice within this chart, now this chart, to give you a background, you can look at the bottom, it says latitude 12.5 degree north. Now, 12.5 degree north is very close to Bangalore and Chennai. Chennai is I think around 13 degree north latitude, Bangalore is around 12.7 degree north latitude. Now, here we can see that during the typical equinox period, the equinox happens twice a year, one during summer 21st and March 21st. There you can see on the chart that the lines which show summer, that is March and September, they start from east and goes to west. So, basically it means that the sun rises exactly in the east and sets exactly in the west. But when you go to the other months, which is the summer winter solstice, which would be for northern hemisphere, which would be December, and summer solstice, which would be your June. So, in June the sun travels predominantly in the northern hemisphere, northern side of the buildings, and in winter the sun is on the southern side. Now, this is a common mistake when especially when I teach in colleges, I see this a common mistake that people draw. When we are asked to do a site analysis, most of us draw the sun path from east, south, west. It is not true completely for Indian scenario. Certain amount cities, especially which is below the Tropic of Cancer, that is 20 to 23.5 degrees, most of them have the sun path or the movement of the sun from the northern side. The cities or the places above those ones only have the sun moving from the southern side. So, beware when we are designing buildings that we need to provide shading on the northern facade, which we ignore it thinking that the sun does not travel there. Now, let us do a small exercise. This exercise will give you a more understanding as to how to read this chart. Let us try to find out the altitude and the azimuth. There are two things which we need to try to find out. So, what time? Let us say 10 a.m. in June. So, 10 a.m. in June is marked with a circle where you can see it. Okay. That will define. So, what will be the altitude of it? So, you could see the concentric circles will give you the altitude, that is 60 degrees, okay, or it could be read as 59 degrees. Okay. So, that would be the altitude of the sun. Now, what is the azimuth? Now, azimuth is basically tracking the center of the position where you are standing. From there, joining the altitude, the point where the 10 a.m., the time when you want to find out where at what location is the sun, like what orientation is the sun being there in the atmosphere. Then draw a line straight from those 2 points, from the center as well as from the point of 59 degrees or 10 a.m. in June. When you connect it to the outer concentric circle, which gives you the azimuth would be 65 degree east, which means the sun is 65 degrees on the eastern side. So, this makes it clear that in 10 a.m. in June, the sun is at around 59 degrees. Okay. If this is your north, if I am facing north, the sun is at 59 degrees and it is southeast. So, it means that the sun is at a particular angle 59 degrees and it is on the northeast. So, we could say it is on the northeastern side, more towards the northeastern side. Similarly you can do a few more examples on it, okay, to get more hang of what azimuth and altitude is mean. Because of the time constraint and everything, I will not go into more exercise of it, but if you have got the understanding that azimuth is always calculated at the perimeter of the thing and the altitude is the concentric circles. To read it, you need to know what time and the month you are looking at it. Okay. So, this is very important on it. Now, what does that mean? Is it useful for architects? Can we do something with it? Yes, we can just look at it and say, okay, the sun is here. But the most important thing which has been put up on the screen is this protractor. This protractor, the shadow angle protractor, is the most important tool for an architect. The reason is this will allow you to design or represent vertical shadow angles and horizontal shadow angles. What does these two do? Basically, vertical shadow angles will allow, in simple words, rather than getting into the complexities of exact definition of each one, in simple words, a vertical shadow angle will allow you to design horizontal shades and a horizontal shadow angle will allow you to design vertical shades. Now, why do we need shading? As we already you would have heard that it is very important to avoid solar heat getting into the building. One of the methods of avoiding solar heat getting into the building is by providing shading, and this has been practiced from centuries, and this is what this protractor will help us to do it, and in a simple manner rather than using computer aided design and everything. This will give you a thumbs up kind of a way when you are working to understand what angle should I be designing my chhajjas or vertical louvers or horizontal louvers or whatever it is. So, let us take the same example, okay, which we did at that 10 a.m. in June. We did that, we found out what the altitude was. The altitude was around 59 degrees and azimuth was 60 degrees towards the east. I think it was 63 degrees east. Now, taking that into consideration, now imagine that you are facing, the facade is facing the east. So, what you do is, as you can see, I have overlapped the protractor over a solar chart. Now, and you can see a central line, CL is been written on the protractor. Now, that central line should be facing towards the east. That means that the window or baseline of the window is facing the eastern side. So, the facade is on the east. Now, from there, same line which you have drawn it will help you get the VSA. Now, HSA and VSA can be read onto the solar chart in this manner. One, if you go back to a previous slide, you can see that whatever is, you have two numbers over there. One, vertical, numbers written from 0 from the outer to the inner, which is 90. That is basically your VSA, vertical shadow angle, which will allow you to design your horizontal shading. Now, left and the right, the numbers from the center line start 0, 10, 20, 30, 40, it goes to 90. Similarly, on the right side it goes to 90. Those are your horizontal shading angle, which will allow you to design your vertical shading. So, when you are clear on that, now when you put the protractor chart onto the thing and we are trying to find out what would be the VSA and HSA at 10 a.m. in June. Now, VSA, if you draw the line from the same red line which we had drawn it previously, you place a protractor over it, you could find out that the VSA, using the circles which are there, the circles which are cutting across, okay, there, and the vertical line which reaches 0, 10, 20, 40, 50, 60, it is there very close to the 60 line. So, that is basically means that VSA is around 60 to 61 degrees. Now, HSA, as I explained you, the center line is over here, either it is on the left as per your protractor or on the right. Now, since the June comes on the left hand side, the line which is cutting through it, you can see it on the outer perimeter that it comes and meets the 25 degrees left. So, whenever you draw or whenever you are trying to find the VSA and HSA, it is very critical that you put this protractor over it, see the lines where it meets. Now, you need to be one thing very careful, that HSA has two values, it could be either right or left. So, whenever you are writing down, please make sure that you mention it left. So, that defines when you are designing a shading mask. Now, let us take the same example of the solar chart which we just looked at. Now, this is a very simple figure or vertical section through the earth and creating an imaginary vault, like as if the sky is just above you to appear. What we are trying to give you is over here is just in simple terms, you can see the altitude of 12 noon. Normally, we have the presumption that it is right above our head, but in this case during winter, the complete right side, you can see that the altitude or the sun angle is at 54 degrees towards the south. But when you look at the summer, the altitude at 12 noon is not at the zenith, it is at 70 degrees on the northern side. So, that makes it very clear, and if you go with the equinox where the days are equal, the nights and the days are equal, there the sun is at 77.5 degrees, which shows that the sun is not exactly at 90 degrees first, which we always have a misconception that sun is right overhead. Second, it also tells you that this graph that northern side, the sun travels in the northern side for a certain part, especially during the summer. So, 79 degrees means there is quite a lot of heat gain into the building, and when is it hot? During summer, and we normally design shading on the southern, ignoring the northern, thinking that there is no sun, but as you can look over here, the hottest part or the hottest days are on the northern side. So, it becomes factoring that we have to consider shading. Now, 79 degrees will tell you that if you can avoid the sun which is at 79 degrees latitude, then your heat gain into the building is reduced during the summer. But at the same time, when you go to the altitude in the north on the winter side, which is 54 degrees. Now, imagine, since a lot of cities in India have a very dual climate, where cities like south side of the city do not experience the different climates, predominantly is one single climate. So, there you would require to avoid it, but when you go to the northern part of India where there is extreme climate like Delhi, then you would allow the sun to come through the windows, heat in sun radiation coming through the windows. So, that will create a heat and you will reduce the heating load onto the building. So, looking at the example, understanding what solar chart is, what are the different methods, understanding how to read an azimuth, altitude, vertical shadow angle, horizontal shadow angle and everything. Now, shading angle. Now, we come down and look, we took an example. The reason we took this example is to give you an understanding as to how the entire process of solar chart works. Now, example is the Indian Technology Center, Bangalore. Now, what I will go about doing over here is, we have taken the example of the Bangalore. I will show you in a picture, that will be much better. This is a building, as you can see, it is a glass building. Okay. Now, we wanted to take this example just to understand how do we look at this building and what is the shading mask. Now, this orientation of the building is towards the northeastern side. As you can see from this is the numbers on the right depict the number of hours the sun is incident onto the window. Now, January there are only 3 hours that the sun will be incident on that window, but when it comes to May, April, May and June, July, and that is the maximum summer in Bangalore presumably. So, when it is so hot, you have 7 hours of direct sunlight hitting the incident window. That means, if you are working, out of your 8 to 10 hours, 7 hours would be predominantly there in that, and especially this happens in the early mornings. So, northeastern is normally in the early mornings. So, when before you enter the office, the building is already heated up. Does that make sense to heat up the building even before coming? So, what does it happen on the air conditioning load? The air conditioning load will increase, and that will have a huge impact on the chillers and everything. So, you require more energy to pump in, to more energy to cool the building. So, this is very important that we design buildings. Now, what I have done is the same building has been facing. So, we have colored the entire thing saying that the window is facing the northeast. So, that is what the black color means. Now, coming down to it, then we looked at how this would have an impact on just the building size. Now, we are not looking at the entire thing, there is no point of covering the entire part, we just looked at covering the northern side. Okay. So, hotter months, basically we looked at only the hotter months, rather than there is no point of looking at the winter months, we thought we will look at the hotter months. In that particular tabulation, we found that 12 plus hours of heat and everything was happening, radiation for 12 hours each a day in hotter months. That is a huge amount of heat that is going into it. Now, that how does it compute with the energy savings? We have done a small example to give you an understanding how this has an impact on it. Now, before we do the calculations, basic calculations, we need to understand what is the radiation received on a horizontal plane in India. Normally from 5 to 6 is pretty much on 0, but when it starts at 9 o'clock, it has around 500 watt per square meter, which means that at 9 o'clock when the office is open, it is quite a lot of radiation that we are receiving on a horizontal plane. Since we are receiving around minimum 500 watt per square meter, and thinking that the hottest month is 9 am, the altitude of the sun is approximately 45 degrees, which means by doing the trigonometry it is same as the vertical incidence as well. So, rather than horizontal plane, it could also be on the same as the equivalent to the vertical plane. So, thus assuming that we will take 500 square meter. Now, before we do this, let us assume that the window height is 1.5 meter high, though the image shows much higher, but we assume that 1.5 meter height from the picture, 1 meter wide. Selecting the portion of the facade, say 30 windows wide and 11 floors high, the percentage of radiation or the glass which we have used, saying that the performing glass is a high end performing glass, is 30%. So, basically it means that it is allowing only 30% of the solar heat get into the building, and the air conditioning is a good air conditioning system with a COP of 4. The electricity drawn by the air conditioning is around 18.5 kilowatt, that is substantial in comparison. Now, let us do a reverse cycle. We know what the basic one is. Now, what will happen if we provide a shading? Now, assume the window was shaded from the direct component solar radiation. Basically, what we did in the previous solar chart, you will see that we shaded the entire hotter part. Okay. So, what happens through that is, then it basically and also why do we need to use a high performance glass? Normally, this has become a trend that you want to build a glass building, but to do that we need to avoid heat. To avoid heat, what we do is we spend more money in the glass, and the glass becomes more expensive, and then you go with double glazing, triple glazing, or highly efficient low E glazing and all those things. Now, in this example, we want to give you a basic understanding, saying that you do not have to go with high end glasses. With a simple glass of clear glass which allows 90% of heat into a building and avoiding the solar heat gain into the building, what happens is you calculate the same thing, you will be able to achieve 3.34 kilowatt. Now, this is almost 20% load lesser than the unshaded glass, which means that you can reduce your heat gain and you can spend less money, reduce the heat gain, which means that your cooling load is reduced, the electricity is reduced, which means that you can have a smaller chillers and all these things. So, shading plays a very important role, and this is where solar geometry plays a critical role in designing it. Now, with the same building, what we have done is we looked at one window, looked at what the impact of the window is. Similarly, we look at the entire building which has been designed over there in terms of the orientation. Now, I know we are doing an eco house, but the point of what we are trying to achieve over here is that even the houses play the same way, whether it is a office building or anything, it plays exactly the same, because the sun orientation will never change. Sun rises at the prescribed time and sets at the prescribed time, the radiation are prescribed, everything is prescribed. So, those will not change. Okay. The only reason we took this was a very interesting example, well known building all around India and everything. So, it becomes very easy to understand it. So, what we have done over here is, as you can look, this is a Google image. Since we just got the images, you can see that the buildings are predominantly oriented north south, where east and west facades are maximum facing. So, what we have done is, the building on the left, we have taken that building to just analyze what would be the impact of the how the sun or heat gain into the building would happen. Now, We have taken the example at 3 p.m. in April, which is the hotter part, and 9 a.m. in the morning, because east the sun rises at 9 and 3 p.m. is the hottest part of the day. So, that is how we have looked at it. Now, coming up it, we have drawn a section. Now, in the section you can see that we have taken the VSA and the HSAs. Now, in this VSA and the HSA, we have said that the maximum, taking the central point of building A, which was on the right side, and building B is the one which is the exterior one in the previous image. You could see 14 to 19 degrees. So, we took that image, and in plan we saw that the bottom one in plan, we saw that the building was around the maximum edges around 26 degrees. So, we drew this overlapping the protractor angle onto the solar chart and drew a shading mask. So, what you need to do in a shading mask is you need to just shade, draw the 26 degree, from 0 to 26 it is shaded. So, when you put it 0 to 26 degrees on the left as well as on the right, the building is shaded. So, it becomes like a flange. Then in the vertical it is 19 degrees on one side, okay, and on the other side it is 22, 23. So, you have got two angles, one on the east, one on the this thing. So, you basically shade those ones. Now, once you do this, the previous figure was drawn to show the elevations of the south building. The next slide, the plan will explain the shading in being inverted of coincidences. So, what it means is basically we have drawn the shading, we know what has happened, the plan, the courtyard and everything. Now, moving forward, we will take the solar chart and draw the same shading what you have drawn it on onto the solar chart, a tracing paper. Position the solar chart on the tracing paper. Now, once you have drawn it, now it gives you a much better clear understanding. What shows it is fascinating, that the sun is not there on the northeast or close to the north, where there is no movement of sun, but it has been shaded. On the right side again it is been shaded. Now, only where it has been getting shaded is on the early side, early mornings. Now, if you look at it, around 7 o'clock the building will be shaded, but what happens after 7? There is the yellow part which is being shown in the graph clearly demarcates that there is direct solar heat gain into the building. Now, that is a huge heat gain which is happening every day into the building, which means that you will require more heat gain into the building, means more cooling. So, that is very, very important. Now, I have given you the tables at the bottom showing that how many in June, how many hours, in May, July and May, how many hours the direct sunlight would get into the building. Now, you can go and play around with this. This is the reason why this is possible. This, and I would put it that this is the worst possible orientation for an office building. Yes, no one will put a building which is east and west. The majority of the facade is facing either east or west. Okay, so, this is how it needs. Now, window of the geometric eastern facade is exposed for 4 to 5 hours during the direct sunlight. The next exercise was proposed to masking the building and orientation of the building. Now, what we did was, we said, okay, if we place around and oriented the building in a different manner, how would that behave? Now, by doing that, we looked at a different aspect of noon, what is the impact at, what is the impact in June, what is the impact in December. Now, based on that, glazing in the northern and southern facades can be shaded differently. Now, one thing which I will finish this up saying it is, before we finish this module, is one basic gist of things that needs to be taken into consideration. First, solar geometry plays a very important role in designing your buildings passively. Second, it is important to understand how the path of the sun moves and it behaves differently for each latitude on earth. Third, azimuth and altitude are of no use unless until you design, you understand what vertical shading angle and horizontal VSA and HSA are. Fourth, once you get the VSA and HSA, it is important that you design shading mask. When you do not do it, there is a huge amount of heat gain into a building, which requires artificial cooling, which increases the energy, and this is where eco houses do not work. For eco house, it is important that we look at passively designing using solar geometry. And the fourth and the last most important thing is, not all orientation have the same shading. Just to give you a thumb rule, east and west could have the same shading, north will be different, south will be different. Northeast could have the same shading, but it won't be the same as the southwest. So, be careful when you are designing buildings. Do not adopt one single shading devices or shading mask for the entire building. It does not work. You need to have different shading for different buildings. So, that is what the entire module was. Being in a very short span, I hope that you have got the gist of what solar geometry is. What we would try to do next is, we would like to give you an assignment. This will make you more flexible and understanding what it is. So, what we have told you is select a window of an existing building that is partially shaded by external obstruction. Prepare a plan, section, elevation of the window in relation to obstruction. Draw those obstructions on a piece of tracing paper. Position a shadow angle protractor. Place the tracing over the solar chart and read the tabulated hours of the days of each month and the year the window is exposed to the direct component solar radiation. Propose a revised shading mask. So, what you have to do is, in gist, is basically take a window, whichever window, whether it is a house or a building, office building, take a window, try to overlap it onto the shading mask, okay, get the orientation. Once you get the entire thing, place it on the solar chart and try to read the number of hours the direct sunlight is coming through the window. Once you know it, try how you can mitigate that, how you can reduce that. This is what would help you out, and I hope this will be very useful in your practice and other things which you are doing. Okay. So, I like to thank you for this module and hope this module is of use in future. Thank you.